Hello everyone. We are going to start course on Introduction to Relativistic Electrodynamics. In my previous lecture, which I named as lecture number 0, I have basically introduced the Maxwell's equation and the details hidden in Maxwell's equation I've tried to describe. It is there in the playlist. Go through that lecture. You can go and check that lecture. Go through that. Today's video is just about the small introduction that we are going to do in the next few lecture. Uh, so basically, we are going to dwell into the relativistic electrodynamics, and for what are the topics that I'm going to cover in this course is basically the small introduction to tensor analysis, where we will talk about the what is the contravariant tensor, covariant tensor, mixed tensors, right? What is metric tensor, how to lower an indices, raise an index, and all that. And later on, we'll discuss about the Minkowski space, Lorentz transformations, geometry of a space-time, light cone principle, Lorentz group, right? And covariant formulation of electromagnetism, all what we have discussed in lecture number 0, we will try to write down in the tensorial form. And then we'll see how the gauge invariance that we discussed in lecture number 0, as I'm referring to, how do they appear in tensorial form, right? And then using all these information and all this knowledge, we'll try to find out how the electromagnetic field of a charge moving moving with the constant velocity. How can that be evaluated? What will be the electromagnetic field that will be generated by a charge particle which is moving with a constant velocity? And what's the coordinate form of Lorentz force law, etc. So for the books that we are going to refer or recommend for this syllabus is the for tensor analysis part, because we don't need very detailed introduction to tensors, so only the concise introduction will be sufficient. So if, this book of the Murray R. Spiegel vector analysis Strom series book, chapter number 8 is there, which is the introduction of tensor, and the same uh, topics can also be covered from mathematical methods for physicists by Afkan and Weber. It is given there. And for rest of the portion, which I've discussed from Minkowski space, Lorentz transformation, covariant formulation, electromagnetism, and electromagnetic field of moving charge, for all this last three portion, we can refer these books, three books. Classical electrodynamics, J.D. Action, which is the most relevant. David G. Griffith, whenever we need some basics or we need to revise or brush up some basics. Of course, some of the uh, relativistic electrodynamics is also given as a chapter in this book, David J. Griffith, and the classical electromagnetism by Gerald Franklin. So all these three books will be sufficient. In addition to this, if we want to go through, we can go to Landau-Lifshitz, Classical Theory of Fields. So this will be sufficient as far as the text is concerned for these particular topics that we are going to go. So in the next lecture, I'm going to discuss about the introduction to tensor, and I'll try to cover all these topics in the forthcoming lectures. Thank you so much.